Okay, I'm going to go ahead and get started. Thank you for coming in this afternoon. This is a presentation that is actually one of my favorite ones to give. It's based on some work we've done around designing very dense virtual machine architectures. What we've found repeatedly as we work with end users is that the average utilization of a server host in a virtual environment is very underutilized. And so we started to work with a few folks, organizations, on how to really increase the density in those environments. The goal was to, in one environment, was to get to 75 Microsoft SQL virtual machines on a single host, and all of those databases were, high performance engines. This is about a 45-minute talk. I only have 35 minutes. And so instead of giving just a real light overview of everything and not really having a lot of value, there's a couple areas that I'm going to really dive in deep into. And then if you want more information, you can certainly talk to me afterwards. So just some background on Storage Switzerland. We're an analyst firm. We're focused, obviously, on storage. As a result of that, we get drug into a lot of virtualization and cloud projects. We work a lot with end users. We work with vendors. We work with those vendors in strategic design and implementation, testing, things like that. You can find a lot of all of our work, actually, on our website, storage-switzerland.com. Feel free to go there. There's new content every day, and we're posting stuff about the show here this week, too. So the big challenge that we see, as I said earlier, is in virtualized server projects is that there's just a lot of underutilization in the environment. We see very few hosts that are above 20% utilization. We'll have an occasional customer that might have 50 to 60% utilization, but that's a pretty rare environment. If you look at the cost of the average host, you could be looking at about a $70,000 investment. That could, I don't know what that translates into euros, but I'll let you guys do that. What that means is that in those environments, you could be paying more for a virtualized machine on a per server basis than if you just went out and got a basic server. So the math was not adding up as well as it should. And I think that this is a good summary of that. What we continue to find is we have plenty of CPU power. In general, we in the IT industry try to be very safe in using that power, because you're kind of counting on that extra capacity, if you will, to handle peak loads and things like that. So that is really what we started to attack with this project. Again, hosts are much more expensive than a standard, off-the-shelf server. So what as we started to kind of net out the true cost of a virtualized project, especially once you factor in networking, additional RAM, and things like that, the cost of the host, as I said earlier, was over $70,000 in many cases, and they may only be virtualizing about 12 virtual machines. So the cost per virtual machine really wasn't that attractive. So we really started to focus on how could we bring that up. And what we wanted to do is essentially build environments that started to look more like this, where we had dozens of virtual machines per host, and the eventual goal was to get to 100 virtual machines per host and have it not crash, right? So you want it actually to work when you get there. So as we kind of looked over this, there became immediately some challenges to getting there. And they really broke down into 4 areas. I'm going to spend a lot of time on RAM today because I think there's a lot of value in that conversation. I'll go through the other areas quickly. If you want to go into any of these in more detail later, certainly grab me after my talk or at any point during the show. But the 4 are the RAM, the storage network, the storage controller, and the storage media itself. So if we look at RAM, one of the big challenges with RAM memory is in almost any server, there's just basically a limit to how much we can physically install in the box. There's also a limit to how much you can afford to buy to put in the box, because RAM is certainly the most premium resource that we have available today. it's also volatile. Again, if you start thinking about an environment where we're dealing with 75 or so virtual machines on a host, we have a lot of things happening in RAM. If I have some sort of power interruption, I have a lot of things that could be in flight in memory with no protection, right? So the risk of failure is quite high, and the penalty if something goes wrong is quite high. So and again, one of the environments we were focused on was a Microsoft SQL environment. So again, we were using a lot of RAM there. So we wanted to make sure we could do this and not put these databases at risk. So how did we were able to overcome this. In this environment, we were typically looking at about 192 gigabytes of RAM. That maxed out these particular servers. And so we started to look for other options. And what you'll see interlaced throughout most of this presentation is a relatively big commitment to solid-state storage. In this environment, we chose to use PCIe SSD. And the reason is we started to look for flash as a very large swap area for memory, right? And if you think about that, if you think about how you normally use solid state, you use solid state to accelerate a hard drive. So what you're comparing it to is, essentially a very slow piece of mechanical equipment. Now, if we're using it to augment RAM, my thing I have to compare to is a very, very fast RAM DIMM. So the performance really became an issue. And it wasn't so much the performance of the flash memory itself, it was the performance of the interface. Okay, so in this environment, PCIe, number one, because it was already available in the account, started to make a lot of sense because I got very, very fast transfers. It also allowed for the creation of very large swap pools. So while we had 192 gigabytes of RAM, we had almost 2 terabytes of internal flash in the system. About half of that was used for a DRAM swap area solely. Okay. What was interesting is if you looked at the page outs in that environment, we were paging to what, in this case VMware, thought was a hard drive often. Right? If you saw the level of page outs that this host was experiencing on a hard drive-based system, it just would have crashed. Right? But because the page outs were so fast, they were essentially almost RAM speed, there was no hesitation at all in overall performance. Okay. Now, if I were to design this today, I don't know if I would necessarily lock into PCIe. The other interfaces have gotten significantly better in performance. So I don't want this to be, hey, those storage Switzerland guys are really into PCIe cards. We are, but I don't think that necessarily precludes all the other ways you can connect storage now. So, but the important thing is that you do need high transfer, right? And you need to have a fair amount of capacity depending on how many virtual machines you have. The other big benefit that we had, I don't remember if I put a special slide in for this. No, I didn't. Okay. So the other big benefit that we had was the ability for this flash to essentially be non-volatile. So we were less exposed on a server crash. The problem was, and this is something we solved recently, is that the DRAM, which sort of links all this together, was still DRAM. Right? So the fact that I had it all on flash was good, but the fact that I had all these virtual swap spaces on flash, once I lost memory, I sort of lost the connection to those virtual swap spaces. So we had to come up with a way not to lose memory. And recently we've seen a lot of work in what's called NVDIMM technology, which is essentially a DRAM module with a capacitor on it and some flash as a backup. Okay? Now what that allows us to do is, on the event of a power failure, the capacitor is designed to charge the memory long enough that I can dump everything that's in DRAM and put it on flash. Okay? So there's a couple of people with laptops here in the room, hopefully taking notes and not tweeting. But if you guys shut your laptops and pulled it back open again, you would generally pick up where you left off. depending on what version of Windows you're running. But generally, your expectation would be that you would be able to pick up right where you left off. That is now exactly what I can do with a server. So if I have a server that loses power for whatever reason, it is essentially like a pause resume on a laptop. This is incredibly valuable when we're talking about big database environments and things like that, where I would normally have to go through a pretty lengthy re-indexing process. So that's been a big gain as well. And then finally, as I said, we only used about half of that memory for a virtual swap area. The other part we used for a local cache. Okay, so we built a read cache. And again, we had to be careful what kind of cache we used. This is a VMware environment. We didn't want to not be able to use vMotion and things like that. So we could only really cache reads, and we had to be careful what software we selected in these environments. But what we were able to do now is cache the reads locally on that server. And again, in these environments, especially the SQL environments, they were about 80% read traffic. Okay? Well, I could take off all of that load off of the storage network. So I get a bunch of benefits from that. Number one, now I have direct access to local storage, high-speed local storage. Number two is I take about 80% of the traffic off of the storage network, which is the next bottleneck I'm going to talk about. Right? So it made for a really nice, clean environment and limited the level that we had to upgrade the storage network itself. Does all that make sense? Anybody have any questions? By the way, nobody ever asks any questions, but if you want to, you can throw it out a question. Okay. So the next challenge we just started to attack this thing top down, and I'll tell you that with the server problem being solved, we were able to really make the biggest process. The value of doing things server side made a big difference in performance. So the next area we looked at was the storage network itself. And in the storage network, we ran into some challenges as we started to really design this environment. The good news is we were actually able to reduce the number of hosts significantly. So one of the first phases of this project was to retire as many older hosts as we could. The value in doing that is that it kind of drove down the overall cost of networking. But at the end of the day, we ran into some issues, mostly because we spent most of the budget on the PCIe SSD cards. We started running out of money for the network. And so Fibre Channel became a problem just from a pure expense standpoint. So we started to look at how we could optimize that. And again, the project we get involved with, we're dealing with real-world people. You don't get to tell people to say, hey, take your entire Fibre Channel environment, throw it out, and get a new one, right? It just wasn't going to be very popular. So what we looked at doing is how can we optimize what we had? And so what we do with the Fibre Channel environment, fortunately, we were able to get the client to 8 gig for most of the real production servers. And then we started to leverage something called MPIV, so we could start tagging specific virtual machines in the environment to make sure that they had priority access. Now, our overall goal was to make sure that everybody, all the virtual machines had the best performance possible, but at the same time, again, living in reality, we knew that there were certain critical machines that if they saw a performance problem would get people fired, and we didn't want to do that, of course. So we started tagging certain virtual machines to make sure that they always had priority access to storage I/O traffic. We never really actually saw an incident where that kicked in that we needed it, but everybody kind of felt a little bit better that it was. Now, we were able to prove that it would work, but in production, we never really saw anything that caused a problem. And then for the rest of the environment, we started to deploy IP where we could. And so in the rest of the environment, we were with a 10 gig NFS-based solution. And that actually worked real well. It was very, very cost effective. The other value that we had, again, because in these hosts, we had virtual machines that were, stressing storage, but not to the level that the SQL servers were. So what we did there is we really focused in on being able to divide up that bandwidth, because the problem that we had with 10 gig was that it wasn't that it was too fast. It was just that there was no single server or host that could really take full advantage of it. So as we started to load up these virtual machines, we're able to carve out certain bandwidth segments for certain virtual machines. And then there's several utilities to make sure that you can use to make sure that all that works together. So our recommendation here is, I'm a big believer in use what you have. So use what you have. And then secondly, as you kind of deploy more widespread, IP traffic becomes very difficult to, or IP networks become very difficult to ignore because of their cost effectiveness. And I felt like we had better granularity in controlling how much bandwidth each individual virtual machine would get. Okay, and also the particular card that they were using, by the way, by a manufacturer, is no longer in business. We didn't select the card, but had the ability to essentially create classes of virtual machines, or you could assign bandwidth to individual virtual machines. Because again, in a 100 server or 100 virtual machine environment, per host, I didn't want to have to go in and for 98 say, medium performance, and then for 2 say high performance. So we're able to sort of group like a working class virtual machine and then a priority virtual machine. The other challenge we started to see is so we've created this flow down where we had these hosts that were able to generate very significant I/O traffic. Then we had a network that could deliver that I/O traffic. And now we had a problem at the storage, and how do we respond to that traffic? And so I think for a storage guy, we took a good approach in not going to storage first. I think one of the concerns I have as SSD and flash become widely implemented is people sort of look at the end of the line prior to looking at the front end of the line. And what we did in these projects is we really focused on the server first, trying to get as much traffic off of the environment as we possibly could before getting down to the storage. So what happens in this point is we now have the ability to really push physical storage hardware. And for the first time not for the first time, but for the first time in sort of a general purpose environment, we were able to flood a storage controller, which became the next real problem is the storage controller challenge. So storage controller is my term for the compute power that is inside a storage system. Okay, so everybody might have their own definition. That's mine. 99% of the time, especially in the non-virtualized world, these things have more power than they know what to do with. They're fine. In this environment, because of the delivery mechanism we had built, we immediately started spiking these controllers with great ease. So we ran into this interesting challenge. This environment, probably like most others, had several storage systems that we could access. And we started to look at which one made the most sense. They had a scale-out cluster environment, and they had a fairly well-powered dual controller environment. The logic would say that the scale-out cluster environment would be the way to go because of all the reasons that the scale-out storage guys talk about. The challenge we saw in the scale-out storage environment is because of the amount of I/O traffic that we are now delivering, we had an environment where that back-end network that connects a scale-out environment together. So scale-out storage, just to make sure we're all on the same page, what I'm talking about there is a node-based system. I'm sure there's 3 or 4 guys like this on the floor. And then the nodes are connected via a back-end network, and then they have share capacity and controllers across that. The challenge we saw is that back-end network started to become just overwhelmed with traffic, because the way these typically work is a file's written, it's broken into parts, and then striped as a secondary step across the nodes. We started to see that back-end network get flooded. And then in the Dual controller system, we just saw the processors just simply get pegged. Where you would typically see that in a dual controller system is where you have a system with just a lot of capacity or a lot of hard drive spindles. These were nowhere near the limits of what the storage system, on the brochure said it would support. So we had an interesting challenge, and we addressed it in two ways. The scale-out architecture we used for the NFS traffic, and we switched to a different architecture that had an InfiniBand back end. Right? That was the only way we could keep up. It drove up costs, but it allowed us to maintain performance. On the scale-up side, we used that primarily for the hosts that were hosting in this environment, Microsoft SQL, Exchange. They had a few Oracle instances. So basically, things that we're doing, sort of back office production things, and we just bought bigger processors. So that was sort of the second thing. And I don't know if we could have done it in a financially responsible way without selecting both. Right? I know that it's very popular to say, oh, well, you just need one thing and go with this one storage system. I don't know if we could have done it with just one system. So this worked pretty well. We only have two systems, which frankly, compared to most data centers, is an improvement. And they are from two different vendors, so they are managed through two different interfaces, which we're working on that as well. The other thing that I'll really kind of address in a bit is the ability to automate starts to become very, very critical in this environment because this particular site, I think, will have more servers than employees next year. Right? So I don't know how that happens exactly, but they will. So the ability to manage all these virtual servers is really going to become a big challenge for them. And I don't see how they do it without some level of automation. So we'll talk about that here in a second. So drives. So now I'm finally at the part that most of these guys out here talk about. So, and that's kind of my problem with a lot of the industry is that we end up talking about how fast is my solid state disk, and there's like 4 other things before you get there that slow it down. Now that said, solid state will make we've proven, you can put solid state into the worst environment, the least tuned environment, and see some performance improvement. The fact that, do either of you guys have an SSD in your laptop? You do? Was it an upgrade? Shoot. I know people who have upgraded. They've replaced their hard drive in their laptop and put an SSD in, and they think it's faster. And it is, because it boots faster. That's the only thing, really, in an application launch, right? There's no way a laptop can generate enough I/O to justify a solid-state device, right? Many times it's going to be battery and size that pushes people that way. By the way, I use SSD in my laptops. But so the fact that it makes a laptop feel faster tells you that you can pretty much put SSD in anything and have the application feel faster. What we needed was an application that actually was faster. And so that was critical that we had all those pieces done before we got to this point. And again, our first action was not to implement solid-state disk, right? Our first action was to see, okay, with what the guy currently had, could we make this work? And so, of course, we looked at putting a lot of spindles out there and basically doing something called wide striping and short stroking. Short stroking is where you only format about a third of the drive. So I'm always using the fastest portion of it. And then wide striping is using a lot of those drives and putting the array group across that. There's a lot of challenges with doing that. Number one, your risk of a dual drive failure in a RAID group goes up significantly. And if you go to any other type of RAID technology, you essentially risk performance loss. The other challenge is powering and cooling and paying for 200 or 300 drives. It just becomes a nightmare. This particular person I've been speaking of is in Dallas, so space is not an issue, but everything else was, so including power. So that sort of eliminated that. So we then turned to solid state, and what we looked at was there's a lot of different options out there. And what we looked at is how can we do this? So in the scale-out system I mentioned, the only way we could get there, at least with today's technology, was to implement a few nodes that were solid state only, and essentially it was sort of a branch off of the main cluster that we used when performance demanded it. The dual controller system was designed from the ground up to have flash in it, so it doesn't use the drive form factor solid state. It uses essentially memory modules, and also the software, if you will, that wrapped around that also was designed specifically for flash. So we sort of had built-in automation right from day one. The challenge we have in that particular environment we found is that, so what I'm talking about essentially is hybrid SSDs. I think they're great, except when you have 100 SQL servers on 2 hosts beating them up. And the problem that we found was that anytime we had a cache miss, the performance difference between the really, really fast solid state, and almost every hybrid system uses what's called nearline SAS drives. So this is a bad example, but it's almost like going from a hard drive to tape on your laptop, right? I mean, that's the delta in performance. So we had 2 options. Buy a third system that was just solid state, just for those situations, or buy enough solid state that the chances of what would be called a cache miss were very, very rare. In this particular environment, we went with that option. We just put a lot of solid state in it so that the chances of a miss were incredibly rare. But it still exists, and if there's one complaint in the environment, it's 4 times a month that the SSD has a miss, right? And users just get used to performance so fast, right? So that was a challenge. In the other environment, in a different environment, we actually went with a third box, and candidly, while more expensive, we've had less complaints, and that one works better. So, you got to kind of balance it. You got to make some decisions sometimes based on budget and things like that. So, 4 misses occasionally is something that they're willing to live with. The important thing in all of those environments was that we clearly needed some level of automation. I've been implementing solid-state disk systems since the early 90s. And they weren't flash then. They were DRAM-based. My first system I implemented was a 4 gig RAM system. It was almost $450,000 for 4 gigs of memory, and it didn't work. So obviously the project didn't go real well. The box worked, but the database wasn't. We couldn't get the database split up enough. Anyways, so these have been around for a long time, and up until we get into environments like this, I was actually always a proponent of what I would call static placement, or not automated. In a database environment, I would identify the hot tables or hot files and specifically put them on there. Same reasoning. I couldn't afford a cache miss or a tier miss. In these environments, I don't know what's going to miss, right? When I'm dealing with thousands of virtual machines, I don't know which one's going to become busy, right? And they're all and it's all different. And we're also stretching resources to their absolute maximum, right? So I don't have the sort of the overhead, the luxury of 70% underutilized servers to kind of compensate. I can't not be able to predict what's going to happen. So what we did is we designed a system that just wouldn't allow for that, and that allowed us to really reduce misses and have it be automated. As I said, the hybrid system that they used in the one account was just sized so big that it wouldn't miss, and it was built from the ground up to specifically use solid state. So we always had good integration there. The scale-out system that used the separate shells of SSD drives had its own automation software built into it, and it worked fairly good. The challenge is, again, remember my conversation about scale-out architectures and how we can really hurt that back-end network with all the traffic. Well, moving data around becomes yet another thing on that back-end network. So that was something that we had to factor into the overall sizing as well. But in general, those work pretty well. I would, as a general recommendation, the vendor community is throwing numbers around when you ask how big should my SSD tier be, of about 3 to 4%, 3 to 5%. I think that's probably very optimistic. I would generally double it to be at least to be safe. Okay, in this environment, you might triple it. So that was the key component in managing that traffic, was making sure we had automation. What was very interesting is in the other environment that I talked about, where we had a standalone solid state only device, we actually leveraged vMotion to do most of the moves, and that worked and has worked fantastic. The only problem is the amount of vMotion traffic that we now do created a whole new project around building a specific server network that was only designed for server communication, which of course added some expense. But so that, the problem with virtualization or any of these projects is when you solve one problem, it feels like you create 3 more. So that really caused a problem there. So I think I've hit all the key points. So what I try to recommend to people is, because we'll talk to a lot of people about this density kind of conversation, and I've sort of given you everything, and most people just don't have the budget to just do the whole project in one fell swoop, and neither, by the way, did the companies that I'm using as a reference. And so pick what makes the most sense first. What I will tell you is that in my experience, addressing the server first tends to be the most beneficial way to go, and then working your way down the system. The exception would be is if you have a recent investment in storage, then it might make sense to implement sort of a cache level, a network cache type of product to give you some acceleration there too. The challenge you have with SSD is there's, I don't know, probably half the vendors on the floor out there have SSD solutions of one kind or another. You could make them all work, right? So you have to kind of find the one that makes the most sense for you. What I found to be the best payoff is to address server-side issues first. The other reason to do that is a lot of time you need business line or business unit manager buy-in and acceptance of what you're doing. And if you can return, the thing that you can do to get that most often is make their applications go faster. And so if you can make that happen, you get a much easier time fixing the rest of the environment. That was certainly what we experienced there. So that's generally my recommendation is start with server side, work your way down, and you got to sort of adjust it to your environment. As I said, the project we've worked on all have different wrinkles, and a lot of it was dependent on budget and what's available in technology and things like that. So that's really all I have. If you have any questions, feel free to ask them. Anybody? Yes, all these were VMware. No, we were constantly monitoring that as we added load. We used several different tools to check that. And we're actually now getting ready to get involved in our first KVM project, so we'll see how that goes as well. But in the VMware environment, there's a pretty fair amount of tools. And also, once I started telling vendors we're working on this project, I was able to get all kinds of free stuff. So that's probably not fair. But so monitoring it actually hasn't been a problem. But what we have found repeatedly is that, like that 75 Microsoft SQL environment that I'm talking about, I feel very comfortable we could take that to 85 or 90. It's just, frankly, the only reason we stopped is we ran out of SQL servers, right? So, which I guess is a good thing. And what we ended up doing just so you know, is once we hit that number, we started moving virtual machines over to another host. I just wanted 2 SQL class hosts in case of failure and things like that. So, just good best practice design there. In the other environment where we did get to 100, none of them were SQL boxes, but they were all, there was a few Exchange VMs and things like that. So they were all, what I would consider reputable representatives of virtual machines. So, next question. Okay. Well, thank you very much for your time. Like I said, I'll be up here afterwards if you have any questions you want to take to me offline. Thank you.